Good morning, afternoon, or evening, everyone. Welcome to today's webinar. My name is Anaiso Frank, the founder of QualitaX, and I'm joined today by three guests. Before we get started with introductions, and as a reminder, on today's call, we will explore the use of blockchain technologies for real-time treasury management in the banking industry. So about the format, we'll have a conversation for 40-45 minutes, and we will leave 10-15 minutes to address attendees' questions at the end. So please do not hesitate to share your questions in the chat as we go. Okay, I think we can switch your camera on now, and we can get started with the introduction. So stop. Hi, Peter. We have also Coenie. So should we start with you, Peter?
Yeah, we can start. Peter Munnings from Adhara. We are a company that builds solutions based on blockchain technology for banks and FMIs. I'll hand over to Coenie to introduce himself.
Okay.
Hi, blockchain engineer at Adhara. I spend quite a bit of time on research and development, and happy to be here today.
Okay, great, thank you. And we have Marelize.
Hi, I'm an engineer at Adhara. I've been working on the cross-chain interoperability solution that we will be talking about today.
Okay, great. So I am aware that some people on the call may not be familiar with today's topic. So before we start, and I like to do that in general, I would like to share some high-level context. So I will share my screen now. Please let me know if you can see it. Can you see my screen?
Yes.
Yep. Okay. So let's say, and this is a very high-level simplified example, but let's say that we have a multinational bank called Global Bank Corp, headquartered in New York, and with two subsidiaries, one in London and one in Shanghai. So every morning, New York needs to collect the previous day's balances and transactions from London and from Shanghai, so that it can produce a consolidated view of cash flow position for daily operational purposes. The challenge here is that there is a lot of fragmentation, with each subsidiary being in different time zones, using different systems, generating different set of data, and having to deal with FX and currency fluctuations as well. And ultimately, this creates delay in data availability and data processing, resulting in increased risk and inefficiencies in cash flow liquidity management as well. So I will stop sharing my screen now, and that's a question for Peter, actually. Would you say that this is a high-level context to start the conversation from? And if so, could you dive more into the business problem and the pain points and application, please?
Sure. I think it's a great place to start, so I can share my screen as well.
Yes, sure. Thank you. And I will.
So let's dive into it. As been mentioned, there are a number of pain points that bank treasurers face, but banking is a balance sheet business, so banks have to manage assets and liabilities, and both assets and liabilities, as we've seen, generate flows, inflows and outflows, as well as all of their risk hedging positions will generate flows as well. And as has been correctly pointed out, pre-2008, mostly banks were looking at end-of-day positions, and then overnight consolidating those positions, and then managing effectively on a day-by-day basis. Post 2008, there has been a shift towards management of intraday flows and intraday positions. So, for example, BCBS, which is the Basel Committee for Banking Supervision, part of the Bank of International Settlements, 248 specifically talks about banks needing to implement tools for monitoring intraday flows. Now, it's one thing to monitor intraday flows and understand where you are from an intraday perspective, but the problem is being able to do something about those, because the current world is a T+T settlement. it's not designed for intraday management of flows. So while many banks have got a pretty good handle now on monitoring their flows, it's difficult to manage their flows. And basically it comes down to the fact that there are three basic problems, or two basic problems really. One is that there are a number of centralized intermediaries, so whether they're central banks, central securities depositories, CCPs, and then there's obviously batch windows, batch processes or window-based processes like the way the CLS does FX settlement. So it's very difficult for banks to then manage their intraday flows and their intraday positions, and that's the major pain point. So we see this growing ecosystem. This is taken from a paper that has been put out by a number of leading banks looking specifically at this problem. And basically what they've observed is this emerging ecosystem of what they're calling digital capital markets ecosystem. And a lot of these platforms are blockchain based. So blockchain-based solutions have a number of benefits in that banks can see the same ledger across different organizations or different entities within an organization. And they're built from the ground up to be interoperable. So there's this interoperable by design layer in the middle here. So there's digital cash, things like Finality or some of the other CBDCs that we're seeing, or bank deposit tokens like JP Morgan or Citi announced recently, or digital assets. And there are a number of those platforms out. They can interop together and enable things like intraday repos, digital collateral swaps, intraday FX swaps, etc. So really starting to enable and address this pain point of intraday liquidity management. Here's a good example. So Fintium is a FX swap platform, trading platform. Well, we just took this off Fintium's website. And so you can see here a typical intraday liquidity view. You can see that this bank on this particular account or currency is going to be going negative. Now, as I said, in the old days, people would only really look at the end of day cash balance, but more and more regulators and banks are interested in this position over here. And so by being able to do an intraday FX swap, they can swap a currency that they happen to be long in for a currency they're short in. So you can see here's the near leg and the far leg of the swap, and it smooths their curve out dramatically and enables them to fall within the lower required buffer, which is now either stipulated by the regulator or stipulated by the bank. So a practical example of something that's already in place. We were involved in this cross-chain FX settlement transaction, the first one, which happened last year in October, so just over a year ago now. And we've continued to work with both companies developing that. The problem that banks are facing, though, is that there's a risk that with these new digital platforms, they will need to start to manage a plethora of gateways, interfaces, data formats, and interop mechanisms. So what we want to do is try and establish some standard patterns, provide guardrails for the platforms to develop, so that from the bank's perspective, it's easy to integrate and to work with these different platform solutions. I think we'll make these slides available, so I'm not going to go through all of this, but effectively banks are needing a professional and real-time post-trade view into these new digital ledger platforms. Some examples: Finality, which is a consortium of banks that is focused on private issuance of central bank-backed wholesale cash on blockchain. HQLX, which does repos. Margin Block, which handles margin. And so basically to have a look at get visibility, professional view of that, but then also to be able to extend these solutions into deposit tokens, DVP settlement processes, etc., for their banking group, and have a holistic view across all of that using APIs, using their own internal. It might be better to show this. So one of the products that we do provide is what we call DC Commander from Adhara, which basically does all of this. So assists treasuries to connecting has some very nice integration tools, and then obviously allows them to do all of these benefits. This is the slide I wanted to get to. So basically, DC Commander sits internally in a bank, can connect to their deposit token solutions, can connect to their front office risk systems, their payment gateways, their treasury systems, the collateral management systems. It utilizes all of the bank side services, and then connects through to these new platforms, HQLX, Finality, Margin Block, other networks, typically through APIs. Some are hosted outside of the bank, some of the components are hosted inside the bank. But this is typically what banks are looking for, to try and join up and start to leverage and take, or start to use some of these new platforms. I'm going to hand over to Coenie, who's going to talk through some of the principles and requirements that have come into Harmonia, which is a lab. So Harmonia Lab was started by a group of banks within the Hyperledger Foundation to start putting down some of these principles and pain points and requirements. And then we'll talk about some of the reference implementations that we've started to create to help cross-chain interop. So over to you, Coenie.
Cool. Hi, thanks, Pete. All right, so as Pete briefly mentioned, I'll quickly mention, we'll talk about some principles that we use to guide how we do both like community involvement as well as some of our products that really enables banks to adopt this new ecosystem, or really helps them along the path. So we've always been sort of anchored in a production implementation philosophy where we make sure that even our proof of concepts, we think of, how will this work in a production setting? So we always need to be answering the questions of, who will be running which component, how will we secure this, which APIs we do need to provide, all of that, is from the get-go, our thinking past is passed into what we build. So our products are also scoped to enable sort of a minimum flow, so that banks can much easier adopt, switch completely across to this sort of new ecosystem, if that makes sense. And then we also ensure that we use distributed ledger technology that has been widely adopted, like Ethereum, as well as then adhere to relevant standard bodies and contribute where we can to those standard bodies, especially in the interop field. And we've also adopted a pattern where we allow, or our thinking is native on-chain assets and participants, not just a view of getting legacy things on chain, but they're sort of first-class citizens on our system. So, or that's how we think, and that's really sort of the principles that we use to guide our development of our products. You can go to the next slide. Okay, so then let's look at, so those are some principles or guidelines. How do we, what are our requirements for then doing or in this sort of space now that's a little bit more research, in terms of interoperating between two different systems. So fortunately, we have rule books in place that govern effectively how the participants, or what they can do, what they can't do, and as well as consequences, and those also help inform a legal basis, i.e., some legal recourse if stuff goes wrong. We also our systems typically work in an environment where participants have wallets or accounts on both ledgers. So, i.e., if you're doing something from a dollar-based blockchain to a pound-based blockchain, you'd have accounts on both. And then what we leverage is effectively a upstream, like for example in the Pete mentioned of Fintium, there'll be a trading venue and there will be a unique ID that will come from the trading venue that will allow you to tie together this trade across the two distributed systems. And then effectively what we require, or what we enforce rather, is to have both parties earmark their funds or assets on both sides before the trade goes through. And then once the trade has gone through, we also said that we have settlement finality that is deterministic, i.e. either both legs go through or both don't. There can't be a time component or a timeout component that adds uncertainty to what the outcome will be. And then we also, since we're dealing sometimes with Ethereum as well as Corda or some other systems, we say that each system needs to be able to generate their own proofs, and we need to be able to then effectively tell another system how to verify or how to understand those proofs. And these proofs need to be decentralized in the sense of each party is responsible for them. That just means that there's no sort of third party involved. There's no centralized piece that is in between, the two participants wanting to execute the trade, other than the blockchain networks themselves that are running.
Just a quick comment. These requirements have come from banks and platforms. So they kind of set the rules, and these we've put into Harmonia, and we've tried to build the implementations, or those people who are contributing implementations, and build them against these particular rules. Right. What we're going to do now is, I think it's more interesting to see a demonstration of one of the implementations. It's based on an Enterprise Ethereum Alliance spec, based on the interop spec. So you'll see lots of references to it. And I'll hand over to Marelize. I'm going to stop sharing.
Hello. Okay, I'm going to demo to you today what you can find in Harmonia Lab. It's a GitHub repository. The flows was extracted from documentation you will find here, and the demo is the integration test that's inside the lab. So I'm going to show you two different flows today, but before we get to those business logics that Pete and Coenie spoke about, we have to ultimately make two different ledgers talk to each other, and we have to do it securely. So for this, we employed the EEA's cross-chain interoperability spec. Very broadly speaking, it allows us to remotely call a smart contract function on an Ethereum ledger after providing proof that something happened on the source ledger. So it is built upon event attestation, even though the spec is not limited to that. So I'm not going to go too much into the spec, but it is structured around 3 layers, and our interop smart contracts and our SDKs are also structured in these layers. So you'll have an application layer containing your business logic. You'll have a cross-chain function call layer, which will enable you to do this generic remote function calls to Ethereum. And it will speak to a messaging layer, which will be responsible for verifying the cryptographic proof that comes with this remote function call. So the two flows that we're going to be talking about. The first is a payment versus payment flow. So we're going to swap some dollars on an Ethereum chain for some pounds on another Ethereum chain. So this is interoperability between Ethereum and Ethereum. Then our DVP flows will be between Corda ledger and an Ethereum ledger, swapping some securities for some cash on the Ethereum ledger. So for PvP, now as Coenie and them already mentioned, we couldn't use any non-deterministic things like hash time locks or have ever a scenario where both one side, one bank has both assets, and you have to rely on legal contracts to somehow remove the hold on your funds. So for that, we used a leader-follower approach that's built on top of this messaging protocol provided by the EEA, meaning we will start with an action on a lead ledger, and we will follow up with something on doing something on a follow ledger, and then complete the process, finalize the process on the lead ledger again. So for this scenario, I'm going to first run you through a little bit of the infrastructure that I set up which is found in Harmonia before we go through the flows. So here, I've just started up 2 Besu networks. So I got 2 Ethereum networks and a signer running. I have deployed 3 Corda nodes, one for Bank B, one for Bank A, and for a notary. I've deployed a Corda app. I've run the nodes, and I've taken note of the public keys because I'm going to need it for onboarding. Then I started a server to talk to the node A, Corda node A, started a server to talk to the node B. Also a Corda decoder service. I will say why this is needed. This will take a Corda transaction and turn it into a Merkle proof. And then the setup. What will we need to deploy on these Ethereum ledgers? So our application layer contract is an XVP contract, which will be able to handle PVP and DVP. The cross-chain function call layer will be, or contract, will be responsible for allowing us to make remote function calls. The messaging layer will be responsible for verifying the cryptographic proof that comes with this remote call. And then the asset token contract is sort of a watered-down version of Adhara's contract. It is different from the ERC20s in that it allows you to create a hold on an asset, not just transfer between 2 accounts, tokens, but first place a hold and then execute the hold. Also be able to cancel that hold. What else do we need to set up? Well, the cryptographic proofs that we use relies on trusted entities, and the rulebooks told us we couldn't bring in a third party, no extra relay or trust validator pool that we trust. We have to use the same consensus participants of these ledgers. So for Ethereum to Ethereum, we will need to let it know there's a validator list that you will upload. Set for one thing. So the second Ethereum ledger will need to know about the source ledger's validators. For if the source ledger is a Corda ledger, it needs to know about the participants of that transaction and also the notary that notarized it. We will have event decoding schemes and event verification schemes for different ledgers. They would look different for Ethereum and for Corda. We will have certain authentication parameters allowing only certain contracts to make this remote function call. And then we also need a mapping in cases, suppose we come from a Corda ledger where we have X500 names and we have to go to account IDs, which might be bigs on the Ethereum ledger. So that's just a few steps of highlighting a few of the onboarding steps that you have to do in the beginning. And then I'll if there's time, I'll run you through what the logs looks like when you run the tests. So to come back to the flows, we start with PVP. So before settlement happens through finality, the Bank A and Bank B would have agreed on a trade beforehand. So meaning that settlement under normal circumstances should always go through. If we bring in concepts of cancellation, it is on edge cases. So they will agree to a trade ID, and then separately will place a hold in the token contract. Bank A will place a hold for Bank B, and Bank B will place a hold tokens on hold for Bank A. They will also mark our application layer contract, our PVP contract, as notary, meaning that the contract can execute this hold. So with both assets being placed on hold, we can start our follow leader or leader follower protocol. So on the source ledger, Bank A will start the lead leg. What would it look like in the contracts? Our application layer will check for cancellations. We will get to cancellations and see why that is important. It will check that the hold exists, talking to the token contract, that everything is in order. And then it will emit an event. Now, this is what we're going to prove to the other ledger happened. And in this event that we're going to prove, we're going to wrap up an instruction of this remote function call that we want to call on the other ledger. We're going to prove that this event happened. And with that, we will prove that all the execution in the contract before that must have happened. Because this event, we only accept events coming from authenticated contracts. So this event will then be caught by an interop service. And a Merkle proof, Merkle Patricia proof, will be built around the event that we will present to our destination ledger. This is not using anything new. It's also called a block header proof. It's using the same tooling that Ethereum already use, or same storage structures. It will use the proof to then perform a call from remote chain to the other ledger, invoking the cross function call layer, which will decode and verify this event. It will initiate the messaging layer and ask to verify the proof. Upon verification, it will initiate this remote function that we wrapped inside of the event data. And for our use case, this is request follow leg. So inside our application layer contract, it will check for cancellations. It will check that the hold is executable. Everything is in order, and it will execute the hold. And then it will emit an event again, which we will use to prove that this was now executed. So the event will be caught by an interop service, wrapped up in a Merkle-Patricia proof, and presented to the other ledger. The cross-chain function call layer will then decode and verify the event. If it verifies correctly, it will initiate the function that we wrapped up in this event to be called remotely. This is complete lead leg in our PvP flow. So checking for cancellations again, checking that the hold is in order, and then it will execute the hold, which will end our happy flow for PvP. So this is something starting on the lead ledger, continuing on a follow ledger, and being finalized on a lead ledger again. Rulebooks tell us there must be, we must handle edge cases where cancellation must be allowed. So for one use case here where we might want to use this is, suppose Bank B does not do as it was supposed, it does not place a hold. We must be able to cancel that hold, but we also want to prevent Bank A being able to just cancel its hold for no reason. So the rulebooks allowed for, or we orchestrated it as such, that you can only go and initiate cancellation on the foreign ledger. It will take some actions that can be proven and prevented to the ledger on which you actually want to cancel your hold. So suppose on this side, Bank B did not place their hold and Bank A did. You could have started the lead leg here. It would have failed on chain because it would not have found the hold. So Alice would submit, or Bank A would submit a transaction, start cancellation to the application layer contract on chain B. And most importantly, the PvP contract will mark the trade as cancelled against the trade ID. And it will emit an event, which we're going to prove to the other ledger, essentially proving that this trade is now marked as cancelled. So the event is emitted, we wrap it up in a proof, we present it to the other ledger, which will then verify that the proof is valid and execute perform cancellation as was wrapped up in the event. And then only then will the hold be able to be cancelled. So here you say that we can see that it checks for cross-chain cancellation or direct cancellation. So when is it then allowed to do a direct cancellation? Well, suppose we get now a scenario that after this whole cancellation went on, the Bob comes or Bank B comes and it places its hold. It must be able to cancel that hold again. In this case, we will call it a direct cancellation, and it will only be allowed if there is already a trade ID marked as cancelled, meaning the whole cancellation flow has already completed. So for that, we cover all possible scenarios to make sure that one side never end up with both assets. Exactly the same will happen on the other side. Suppose Bank A does not place its hold and Bank B wish to cancel, it has to go through the lead ledger. I'm not going to go through it, it's exactly the same. I rather want to go through the DVP flows, which is delivery versus payment, coming from a Corda ledger to an Ethereum ledger. So Corda is a little different in how it updates its states. It doesn't really update the state, it consumes existing states and it creates a new state. So to our Corda app would have a DCR state. This was working with HQLX as a digital collateral record. It is just a basket of securities that has an issuer and can be transferred to a new owner. We had to push for them to add earmarking functionality to this security basket of securities before it gets transferred so that it can fit into these flows of ours. We also had to add a state, Corda state, to track the trade in the name of cancellations, and that will hopefully become clear as we go on. So we assume that this basket of securities was already created and it's ready for consumption, and the trade was already also created. As before, we agree on a trade ID beforehand, before settlement starts. So as with Ethereum to Ethereum, Bank B will place its hold exactly the same and make it perpetual. And on Corda, this basket of securities will be earmarked. Now, this on Corda looks like a Bank A will create a draft transaction, creating a new DCR state, which will then have status earmarked, consuming the current available one, and it can only be consumed once. So Bob will then validate the transaction, which is before he signs it, which is important because we're not using validating notaries. Notary will attest that the inputs are unique and that this transaction did happen on the Corda ledger. So this is now where we would have had an event on the Ethereum ledger, and we will wrap it up in a proof and present it to the other ledger. But Corda doesn't have events. So we took the next best thing. We took the Corda transaction and we wrapped it up in a Merkle proof, using still the same consensus participants that was involved in the transaction on the Corda ledger. So participants, Bank A, Bank B, and a notary. So ideally, we would have wanted a Corda service here to start the lead leg and create a proof and call the Ethereum ledger. But our infrastructure was not as such that the Corda side had access to the Ethereum nodes. So we set it up like an instruction being sent to our interop service, which will create a Corda proof, which is what that Corda decoder that I started up in the Harmonia lab was about, and then be able to perform this call from remote chain to the Ethereum side. So Bank A, Alice, will out of her Corda vault take the signed Corda transaction and submit a settlement instruction. The Ethereum interop service will wrap it up in a Merkle proof, a multi-valued Merkle proof, which is still using the same Merkle proof structure that Corda uses. And it will present a Corda proof to the Ethereum side. The function call layer will then route it, knowing that it is a Corda proof making use of the system that submitted the proof. It will verify it upon correct verification. It will then execute the function that we said we want to remotely initiate. This time it is not wrapped up in an Ethereum event, but it is sent with this proof, and we pull data out of the Corda output parameters, and we validate it against the remote function input parameters that we want to call here. So the same will happen as we did with the Ethereum case. The hold will be executed and an event will be emitted, attesting to that happening on the ledger. It will be wrapped up in an Ethereum proof, and via a callback, it will be given back to a Corda service, which will then initiate a Corda flow. So the callback was given to us when the settlement instruction was submitted. This is the callbacks can be changed at a later stage if our Corda app was a little bit more evolved into being able to have interop layer states that we can interact with directly. But for now, the Corda service will then initiate the Corda, the confirmed DCR flow. This would be like complete lead leg if for its Ethereum equivalent. So it will consume input states of a earmarked basket of securities, and it will consume the trade that we created. Again, can only be consumed once, and then it would output a new basket saying that it is now transferred to the new owner. And this will only be allowed to execute. The Corda app will ensure this once the Merkle Patricia proof coming from the Ethereum side was validated. So then just as to close off briefly, what will happen when we need to cancel? Suppose the Ethereum side does not place their hold and the Corda side does. Bank A will have to cancel through the foreign ledger. So it will initiate a Ethereum application layer function in the DVP contract that will mark this trade as cancelled. It will emit an event that we will use as proof to feed back into the Corda system that will only upon verification initiate or complete the cancel DCR flow. It will consume the XVP state in its created state and the earmarked DCR, and it will take the basket of securities back to an available state. And then we must also cater for the case where Bank B comes after the fact and places its hold. It must be able to cancel directly, and this works exactly the same as on the previous Ethereum PVP example. Other way around, if the hold on Ethereum is placed and the Corda side does not place their hold, Bank B must be able to cancel via the Corda ledger. So it will initiate a Corda flow to cancel. The only thing that gets consumed here is the trade state, the XVP state, that must be in a created status. And we will output now a cancelled trade state. And this will be used later. Sorry, if we go down. Will now be used to prove to the Ethereum ledger that we have cancelled. We will build a Corda proof from this raw signed Corda transaction presented to the Ethereum side. It will be validated, and after verification, the enclosed instruction will be executed, which is perform cancellation on the Ethereum side, which then mark the trade as cancelled and cancelling the hold. Then if the Corda side afterwards places their hold, they must be able to cancel directly. And they can only do this if there is a trade state that's already in a cancelled status. So only if these previous flows for cancellation happened, through the Ethereum side. We go back to our demo. Here, if you want to, you can go look or walk through the flows step by step as they get called. I just want to go to a nice one. This is the DVP, sorry. Yeah. So if you look at creating a hold, you will make it perpetual. You'll be able to step through it rather easily. And when the settlement instruction gets submitted to the system, when we call start lead leg, we will get our receipt. When an event was emitted to do this remote function call, how it gets wrapped up in a proof, how it gets presented to the other Ethereum chain with a perform call from remote chain, and how an event gets emitted again and sent back to the lead ledger with a perform call from remote chain and receipt. And in the test, you will see that balances gets checked in all defined details. There's the same as for the DVP test. You can step through the logs if you want to. And I think that should conclude the demo. I hope I'm not over time.
No, this is perfect. Thank you very much. And it's a lot. Oh, let me share my camera back. So I will try my best to do justice to the presentation from Peter and Coenie and your demo by summarizing what I understood. And please correct me if I'm wrong at some point, and then we can open for Q&A. Can open the floor for Q&A. So first and foremost, Adhara does have a solution to facilitate real-time treasury management within bank groups. So that's the first high-level example that I started the webinar with. And this solution is called DC Commander. Now, Adhara is also involved in the Hyperledger Harmonia initiative, which is an initiative that was set up by a group of banks to explore interoperability and all layers, not only the technical side, but the regulatory requirement and the legal requirement as well, to understand how to interoperate between different ledgers. So during the presentation, we talked about an example of two banks, banks A and B, and two ledger, or a Corda ledger and an Ethereum ledger. And we went through two use cases, PVP, so payment versus payment, and DVP, delivery versus payment. My first question, just to clarify for the audience, is that when we talk about ledger A being a cash ledger pound, ledger B being cash ledger USD, for example, are we talking about tokenized cash deposit?
I'll answer that. Maybe if I can just show you a couple of real examples.
Yes, that would be very.
So we've got a couple of early adopters of this. So in these cases, these are all cases, different types of cross-chain.
Okay.
So this first one was debt issuance. So the debt instrument that was issued against cash. So the cross-chain was the security, was the debt, and that was the cash leg. We've spoken about Fintium, which is FX, so cash, one currency for another currency.
Yes.
And then more recently, Goldman, Santander, UBS did a trial with a repo settlement with Finality and HKLX, high quality liquid asset exchange, which is a repo exchange that's owned by the Deutsche Börse. So these are not just theoretical examples; these are being used in real world scenarios. And these are the ones that are public. So these are what we would call backed by settlement tokens or interbank tokens, typically backed by central bank money. But then there's a whole range of what we would call deposit token solutions, which is banking group or bank deposits that have been tokenized.
Yes.
So JP Morgan have announced their repo settlement using JPM coin with a bridge repo. And there's a couple of others in that space, and there's a number that we're working on which are not public yet, where bank deposit tokens are being used for settlement. So we're seeing it both in the interbank market as well as on deposit tokens within banks.
Okay, so that's helpful. So basically, you did mention that right now those are theoretical, and I know that within Harmonia, we are talking more about proof of concept right now. Is there anything in production yet? And based on your understanding of the market, and this is a question for yourself, Marelize, and Coenie as well, how far are we from seeing the first production ready, I would say, deployment?
So JP Morgan Broadridge is already in production. HKLX have got what they call a DVD product. So it's a basket of dollar-based securities for a basket of sterling-based securities. That's already in production. It's already been traded with quite significant volumes as well.
Okay.
We know that Finality are going live with their first currency this year, so it doesn't give us much time. So we expect an announcement. They've just announced their Series B funding.
Yep. That was last week, I believe. They announced a few days ago. Yeah.
That basically those banks had to be pretty sure that they were going to go live. So we're pretty convinced that they will be going live shortly, imminently. And then so there are a couple that are already live, and there are a number that are will be going live early next year. So they either live or pretty close to going live. I think we're just going to see this marketplace grow.
Okay. And with the acceleration of proof of concepts and trial from different governments regarding wholesale CBDC, when it comes to Adhara's product, but also the being able to rely on wholesale CBDCs for settlement for the different use cases, what do you think would be the impact? Would that more accelerate, I would say, the deployment of those solutions versus cash tokenized deposit and all the narrative around tokenization in general?
Yeah, I think the more press that comes out, obviously the big interbank or central bank backed settlement tokens get a lot of press because they definitely help add to the momentum. But what we're seeing is that the banks are getting on with their deposit token solutions regardless.
Okay.
So it definitely helps add to the momentum in the broader ecosystem. But what we're seeing is that many of the banks, they work in the currencies they work in. They work with the securities platforms that they work with. So they're not waiting around for CBDCs to facilitate their settlement. They're starting already with their own deposit token solutions, and then if CBDCs come along, and as they come along, they will augment the process and open up additional markets for them, but they're not waiting around for those things to happen.
Okay, that's great. And I do have one last question, and then we open it to attendees. So there is a lot of innovation happening really fast in the permissionless space when it comes to interoperability. We have different ecosystems, layer 2 ecosystem. We have a lot of development in terms of zero knowledge technologies as well. So it seems to me that all of those innovations will start leaking very slowly into the permissioned space as well. So in terms of zero knowledge technologies, are you currently seeing any solutions being proposed that could support interop between banks or within, or I would say, let me rephrase, zero knowledge based technologies for financial market infrastructure of the future?
Yeah, I'll take it. Well, we're looking into, you can almost say, the race of the layer 2s or the race of the zero knowledge EVMs. So we use a Merkle proof in our solution to prove that something happened on Ethereum ledger. So your zero knowledge EVMs they create circuits where you can validate a transaction and then provide this proof of this execution. So we can also use this for interoperability, of course. Block header proofs is just a tiny little bit more expensive than what they would call a snark proof. So it wouldn't really make that much sense. But if you come to Corda proofs, which is very, very expensive, and there's improvements that might come with Corda 5. But then you can start to think of wrapping up the proof. Instead of having a Corda Merkle proof, you'll have a Corda zero knowledge proof that will be a fraction of the gas costs. But I have not seen anyone working on a Corda zero knowledge JVM. So, but for Ethereum, those toolings are Polygon and Linear has already got 2 EVM equivalent zero knowledge circuits that you can use readily.
Yes. Coenie, do you want to add something?
No, just that the great part about the zero knowledge proofs in this space is really to that scalability effect, right? So initially we'll probably see that layer 2, layer 1 scaling, i.e. like on-chain, you have for your native asset, you have scaling, but then hopefully that will translate into being able to scale interoperability between multiple ledgers as well, using similar mechanisms. So that's really exciting. And it all uses similar technology. So we already see sort of efforts in that direction for the enterprise or closed network space, but none yet that already sort of use.
Okay.
For me, one of the stumbling blocks is going to be the regulators. They really do. They're trying to move along with the technology, but it's quite hard for the regulators to get their heads around zero knowledge proofs.
Yep.
And they also, at the moment, they're very concerned about quantum, future proofing your proofs for quantum computations. So some of them do work, some of them will work better than others. So we definitely, technically, we see, and we're experimenting a lot and working, exploring a lot of the ZK, especially on the EVM side, what can be done. And we definitely see it as an option technically. I think there's still a lot of work to be done with the regulators to get them to understand what the advantages it brings and what it can do. And so whether you're doing layer 2 against, say, something like a public Ethereum beacon chain, or layer 2 against a permissioned, layer 1 chain, conceptually they're the same. And there's a lot of companies working on both solutions. So definitely, as you say, we're seeing some of the benefits of the public chain technologies, not just leaking, but moving quite quickly into the enterprise space.
Yeah, as I'm concerned, I'm quite happy about that. And I don't see any question in the Q&A section now, so I will ask one last question. There have been a lot of announcements regarding trial of tokenization of bond or bond settlement on public ledgers. We saw Société Générale in France, I believe. We saw in Philippines, I believe, last week. I don't remember exactly. So what do you think will happen in 5 to 10 years' time if some layer 1 and layer 2s are able to establish themselves as core infrastructure similar to what we have on the internet side, so that the security has been proven, battle tested, the infrastructure has been, I would say, proven as reliable and resilient enough? Would we see the traditional finance industry being more confident with using those public and shared infrastructure rather than relying on permission or consortium network? What would it take for this to happen, if ever this happened?
It's a very good question. I don't know if I know the answer for that, but the regulators are certainly very nervous still of public chain infrastructure. I think the banks are very nervous about the hidden costs of that as well. So I think everyone's trying to understand what would happen if there was true volumes put onto public chains. Would they be able to cope? I think the move by Ethereum into proof of stake is definitely helping, and the tremendous work that's happening on the layer 2 side of that is definitely helping. And you know, as you say, we've already seen some real money transactions happening on public chains. So it's not miles out there. You know, I think on the security side, like you're saying, we probably will see movement sooner than cash. So from our perspective as Adhara, you know, we provide product to banks to be able to connect to either permissioned networks or
Okay.
public networks. And we've done a project on the public network already. So we don't really mind, and we always tell the banks, you know, if it does ever move in that direction, the product that they have from Adhara will be able to support those securities or whatever we see there. So from our perspective, we don't mind, but we do see a lot of resistance from both the regulators and the banks to move they're happy to do some experiments and some small value transactions. But I think there's still a lot of concern about moving high volume, high value transactions onto public networks. But like you say, 5 to 10 years time, things may have changed significantly, and probably only take 1 or 2 big events where it becomes obvious that moving to a public chain has benefits around resiliency or whatever it is. So we do, you know, we always have that as an option in terms of our own product design.
Okay, great. Well, we have 4 minutes left. Is there anything you would like to share? Coenie, Marelize, Peter, if you have anything, we can. Yes, go ahead.
Sure. Maybe I can just add my sort of 2 cents to that. And again, this is just my opinion, right? I don't have a crystal ball, but and I think so one of the benefits what Adhara has is because we've built on Ethereum, we have that sort of easy capability of moving to a public ledger should our clients want that. But that said, though, I think that the problem with cash for central banks is jurisdiction. So they have absolute control over their systems currently. You know, how often or how redundant they are, the redundancy around the security, the everything, and letting go of some of that control onto a public sort of or a common ledger like Ethereum that has, you know, people staking in, you know, China or the US or the EU or in North Korea, even you don't know where those, you know, it would be hard, I think, for a regulator to swallow, you know, and move and take that step, you know, moving from a place where they are currently at, especially for cash, because it's there, it's the thing that they're responsible for. Ultimately, that's what they're responsible for, is ensuring their currency is secure and safe to use and promoting it, right? And putting things in place that make other people want to use it. So that's sort of I think the hardest one to solve for is the problem of jurisdiction is as soon as so that makes it quite different from the internet, right? So the internet is you have some information flowing over there, but it's not, you know, if the one link is down, then you use the satellite link or you use the, you know, whatever link. to get your information across. But it's also to perhaps a different country or within your own borders. But when it comes to your asset or your currency that you use as a country, I think that it'd be quite hard to move that to somewhere else. But that's just my very maybe yeah. Okay.
Yeah, it's very insightful. So thank you for sharing with us, Coenie. And thank you, Peter, Marelize, attendees as well to have joined the call today. And on that note, well, thank you again and bye for now.